Hello Internet, this is the High School Scientist, and in this video I will be explaining all the dimensional formula for every physical quantity. But before that, if you only want to know or learn about a specific quantity, then I have mentioned the timestamps in the description below, but I really recommend that you watch the entire video. So every fundamental quantity is denoted with a capital letter, and using these letters I will derive the dimensional formulas. So let's start with length, which is L, for time is T, for mass it's m, for temperature we use K, for current we have A. We also use mole for the amount of substance, but we won't be using that much. So using these symbols I will be explaining dimensional formula. So let's start with frequency. Frequency can be explained in many different ways. Its expression is 1 by time. Now what do you do with the inverse of time? Just think of it as the time taken to complete one task. It might be any task, and how frequently can you do that task depends upon the time taken to complete it. Okay, so now every wave has a frequency, and the number of cycles completed by the wave in 1 second will be the frequency of that wave. For example, if you drop a small stone in still water, you find that the waves move in concentric circles. So to know the frequency of that wave, you would have to count the number of to and fro motions completed by that wave in 1 second. Fun fact, radio waves, microwaves, X-rays, gamma rays and even visible light are made up of the same fundamental particle, and just the frequency of that particle tells us what kind of radiation it is and how much energy it has. So that's it for frequency. Let's move on to the simple stuff, like area. Now its expression is length times breadth, but breadth is also a type of length, so the dimensional formula is equal to L square. Next up, volume. We have area times height. The dimensional formula for area is L square and height is L, so the dimensional formula for volume is L cube. The expression for density is mass by volume, so it becomes m by L cube. But in dimensional formula we do not use fractions, so we have to convert it to m times L to the power minus 3. Velocity. Velocity is the change in displacement in some time, that is length per unit time, and just by replacing the formula with the dimensional variables we get L times t to the power minus 1. Acceleration. Acceleration is the increase or decrease in velocity in a period of time. Its formula is velocity by time, and by replacing the formula with the dimensional variables we get L times t to the power minus 2. Momentum. Force acting on a body is equal to the rate of change in momentum. Its expression is mass times velocity, and so its dimensional formula is mlt to the power minus 1. Force. Force can be defined as mass times increase or decrease in velocity over a period of time. Its expression is mass times acceleration, and since we know that acceleration is L times t to the power minus 2, the dimensional formula becomes ml times t to the power minus 2. Next up, energy. Fun fact, the entire universe is made up of energy, and every particle in the universe wants to get rid of energy as much as it can. But in mathematical terms we describe energy as accelerating a body with mass over a distance. Its expression is force times distance, and dimensional formula is ml square times t to the power minus 2. Next up, power. The amount of energy spent in some time is defined as power, or the amount of work done in a period of time is what we call power. Its expression is work by time. We know the dimensional formula for work, which is ml square times t to the power minus 2, and when we divide this formula with time, we get the dimensional formula of power, which is ml square times t to the power minus 3. Impulse is the amount of force applied on an object multiplied by the duration of contact with that object. So greater the time of contact, greater the impulse. The expression is force times time, and the dimensional formula becomes ml times t to the power minus 1. Pressure is the force applied on a unit area. And so the expression is force by area, which means if you have force acting on a large area, then the net pressure is low, and vice versa. And the dimensional formula is m times L to the power minus 1 times T to the power minus 2. Now let's move on to something a little more complicated. Surface tension. Now this might take some time to explain, but stick with me on this and pay attention. Now surface tension is a property unique to fluids. Okay, so for example, we see that every water droplet is spherical. But have you ever wondered why? It's because of surface tension. The outer surface tries to be as small as possible, because the water molecules attract each other, and out of all shapes, a sphere is the one with the least surface area. And that's why the water droplets are always spherical in shape. Now let's try to explain this mathematically. Let's take a beaker of water and gently drop a needle onto the surface. We see that the needle floats, but the density of the needle is much greater than that of water. So why does it float? This is because of surface tension. As the molecules of water can withstand the force exerted by the needle with their force of attraction. So let this needle be the diameter which makes up the surface area of water. And to find with what force is one side of the water body attracting the other, we can use this formula. Force by length, which is equal to surface tension. And so the dimensional formula is m times T to the power minus 2. Another fun topic is moment of inertia. What exactly is moment of inertia? Well, it's just a quantity or a ratio which tells us the amount of resistance a body can have against angular acceleration. That is the tendency of the body to resist angular acceleration. Now, it's okay if you don't understand. I will be explaining this topic in detail in my upcoming videos. Now the expression is mass times distance square. But what can we measure using kilogram meter square? Well, moment of inertia helps you to measure how much of torque, which is the amount of force you would have to apply before the body starts to move. Meaning the greater the m times r square, the greater torque you would need in order to accelerate the body or a particle around the axis. Angular velocity. It is the same as linear velocity, except instead of using meters per second, we use radians per second. But we cannot use angles in dimensional formula. So what do? We just discard radians and just use time. And this is where we start to see the drawbacks in using dimensional analysis, as we cannot describe angles or any constant values in the dimensional formula. So the dimensional formula is T to the power negative 1. Angular acceleration. Now the expression is angular velocity by time. We know that angular velocity is T to the power negative 1, and so the angular acceleration becomes T to the power negative 2. I have made a video explaining angular acceleration and angular velocity in detail. Now let's move on to angular momentum. Linear momentum is just force measured at an instance. I have made a video which explains momentum in detail, and so check that video for more info. Now angular momentum is a bit different from the other angular quantities, as it does not require any angle. We know that the expression for momentum is mass times velocity. And so in angular momentum, we just have to multiply this mass times velocity with distance. And that becomes the expression of angular momentum. And thus the dimensional formula is ml square times T to the power negative 1. And now I guess it's time to end this video. I would continue with the rest of the dimensional formula in my upcoming video. So I hope you learned something, and if you did, just spread the word, let your friends and classmates know about this channel. This is the High School Scientist signing off.